Okay, so it's going through and boom, it crashed. What's up, ladies and gentlemen, it's Ryan here, and today we're going to talk about Goroutines and what happens if you don't take control of your Goroutines. So here I have a very simple application. It has something called an event manager. It has something called a stream, which is really just a channel, a read-only channel, and we're going to pull events from that channel and just print it to the log. This event manager is going to produce 10 events per second. So what we're simulating here is an event-driven system where you're pulling in events from, say, Amazon SQS or from a database or from WebSockets. It could be anything. It doesn't really matter where it's coming from, but the bottom line is it's a stream of continuous data, potentially an infinite amount of data that we need to continuously process. So let's go ahead and run this and see what happens. Okay, so we can see that it's just a continuous stream of events. It's not actually doing anything. It's literally just pulling the event from the stream and printing it to the log. So now I'm going to add some actual processing to this. So we're going to add something called a processor. Create processor. So instead of logging it, we're going to say processor.process event and then pass in our event. You don't have to know what this processor does. All you have to know is that we're processing the event, whatever that might be. You know, event-driven systems, an event can represent anything. Like on YouTube, when you upload a video, it's going to trigger it to transcode. There's probably a service that's going to transcode the video. Every time a person leaves a comment, that's an event. Every time a person clicks subscribe, oh, by the way, please subscribe, that's an event as well. So any action that a user takes on a platform can be processed as an event, the same way we're doing right here in this application. So let's go ahead and run it. Okay, so we can see that it's receiving the event and it's processing the event. It's kind of slow. All we have to do is say go, and now let's run it again and see what happens. Okay, so now it's way faster. It's no longer blocking for each event, but it's actually processing them all concurrently. And one thing worth noting here is I applied a limit of 200 megabytes for this service. And since I'm running it in Docker, Docker allows me to see the CPU usage and the memory usage and even the network usage as well of this particular service. So that's one reason I like using Docker locally. Also, usually once you deploy something to production, it's going to be on Docker anyway. So you might as well run it locally in Docker. So what I'm going to do here is run the app and set it to create events at 300 events per second. And that's how quick it's going to try to process those events, and let's see what happens. Okay, so it's going through and boom, it crashed. So signal killed. So on your backend, if you're working with Kubernetes or Amazon Web Services, whatever it is, and hopefully it tells you why your service crashed, it'll say OOM killed or out of memory killed. So each time you process the event, it needs a reference to the event and all of that data, right? So as long as that Goroutine is running, the event is going to exist in memory. So here I'm running it again, except this time it's going to print the number of Goroutines that are running concurrently. So we can see, boom, it crashed again. Yeah, it seemed to cap at around 40 Goroutines before it killed the process. So what we can do to prevent this program from crashing is to apply a limit to how many concurrent Goroutines can run for this particular part of the application. Okay, so here what we can do is say limiter equals make a chan. I'll just make it type int. It can technically be anything. It could be bool, it could be string, it could be whatever you want. I'm just going to make it an integer. And with this Goroutine, we need to take a little more control over that. So I'm going to bring that out into an anonymous gofunc. As such, we need to copy this event into the scope. Okay, cool. So we got this copied into the scope now. So with our limiter, we're actually going to make this a buffered channel. So I'm going to say 8. I'm going to have it perform a maximum of 8 Goroutines concurrently. Down here, we're going to say limiter, and then we're going to add an integer. It doesn't matter what number it is. It could be whatever you want. The whole point is that every time a Goroutine is added, it's going to add to this channel. And then in here, when it's done processing, we're going to pull out the value from the channel, which is in turn going to leave space inside the channel for the next Goroutine. So it can be a little tough to wrap your head around how this works because it's using the magic of channels, and it's taking advantage of the fact that channels have a blocking behavior that happens whenever a buffered channel gets filled up. So anyway, let's run this and see how this changes things. Okay, sweet. So already we can see the number of Goroutines is 8. We can see it's steadily processing these events, and we can see our memory usage seems to be capped at around 60-70%. So cool, now our program is not crashing anymore. Now it is gonna lag behind a little bit until it can catch up and process all the events, but one thing it's not gonna do is crash. So what we might wanna do here is just gradually increase this as much as we can get away with. So I increased it from 8 to 12, now I'm gonna run it again. Okay, memory usage is going up to 80, 95, 97. Usually garbage collection is going to kick in. Let's see. Okay, it's staying pretty steady at around 95%. We're cutting it a little bit close here. I don't know if I would feel very comfortable with it being that high, but I think what I would do is sort of compromise it, go to 10 seems like a good compromise. So we run it at 10 and let's see what the memory usage looks like now. Okay, so it's at about 80. Okay, so this seems like the sweet spot right here. We're capping out at around 85%, 75. Garbage collection is doing its thing, and we're processing events at a pretty decent pace. It seems like every year the garbage collector gets better and better. Obviously, it can't entirely prevent an out-of-memory crash. So again, I set a limit of 200 megabytes to my service, and that might seem kind of low, but in reality, when you're talking about microservices, right, these are not full-blown services like monolithic servers meant to do everything. This is just one specific server meant to do one very specific thing. And so it is perfectly normal to limit these services to only a few hundred megabytes and not allocate like gigabytes to them because they don't actually need that. You might have an authentication service, you might have a billing service, you might have a video transcoding service, an image resizing service. You'll easily end up having dozens or at some point maybe even hundreds of different microservices, just allocating a couple hundred megabytes to each one. So that said, I think it is a good practice to try to be memory efficient in how you build your applications. Just because your computer, your personal computer has 8, 16, 32 gigs of memory doesn't mean that once you deploy the code to the cloud that you're going to have that same amount of memory. So yeah, Goroutines are a powerful tool. They definitely make your program perform better and faster, but it's just something you got to be careful with. If you go willy-nilly just spawning Goroutines without any limits, you might find yourself running out of memory. So as usual, it's Ryan here. If you like the video, please like and subscribe, support a little YouTuber like myself, and thank you for watching.